Happy Wednesday, everybody! Hopefully, you had a good day yesterday, and I'm looking forward to getting through today's lesson with you. So, yesterday we started talking about finding the mean, median, mode, and range, and today we're going to look at finding the interquartile range as well as interpreting or figuring out what it means to have these data points that we've learned how to calculate. So go ahead and make sure that your notebook is set up with your uh, paper titled Chapter 8.2, Interpreting Mean, Median, Mode, and Range, and Interquartile Range. And then we'll go ahead and get started with the notes. Don't forget that you can pause along the way so that you can copy down the notes as we go. Okay, so some of the pieces of information that we kind of need when we're looking at a set of data is, are the numbers close together? Are they spread out? What does that kind of mean when we're looking at our data set, and how can that affect our measurements, our mean, median, mode, and range? Well, one of the things that affects it are called outliers. And an outlier is an extreme value in a data set. So if we're looking at numbers, 1, 2, 3, 4, 5, an outlier would be like if I added the number 500 to that data set. So with everything being 1, 2, 3, 4, 5, and then we add, 500, that is a value that is much larger than the rest of the numbers in the data set. So an outlier can be much larger or much smaller than the other values in the set, and this tends to really mess up the mean and the range. So the average and the range of numbers is messed up by these outliers. So here's an example. If we look at this data set that I just wrote down, it's 5, 6, 7, 8, 9, and 37. So most of our values are between 5 and 9. However, this big old number down here at the end, 37, that would be our outlier. So that would be our outlier. Or if I went over here and added like -2, that's a really far number away. So that would be an outlier in the other direction. Make it look like a 2. So an outlier are values that are much larger or much smaller than the other values in the data set. There are two different specific measures that we look at when we have a data set. The first one is the measure of center, or MOC. And the measure of center literally measures the center of the data. And we use these measures of center when our data set could possibly have outliers. So, there are two ways to find the measure of center. Which one we use depends on whether or not there are outliers. If there are outliers in your data set, you're going to want to use the median. Because the median will kind of be that middle number once we're crossing off left and right to find that number in the middle. It kind of gives us an easier balance. If there are not any outliers, we use the mean or the average. Later on in this chapter, we're going to look at how the adding or taking away those outliers can actually impact our measures. So knowing which number or which value to find will be really helpful to find the center of our data set if we have outliers or don't have outliers. The second measure that we look at is the measure of variability, or MOV, and this measures the spread of the data, so how far apart the numbers are in our data set. So there are two ways that we can find our measure of variability. And those are the interquartile range, or the IQR, which you're going to learn how to find today. And the other is, if there's not, we're going to use the range. So remember, our range is our largest number minus our smallest number. So you can see that those two ways are how we're going to find how spread out the values are in our data set. All right. Okay, so the big fancy word that we're learning today is the interquartile range. So when we're finding the interquartile range, we're trying to find the exact center, or the middle of all of our data. So to find the interquartile range, you're going to put the data in order from least to greatest, which we already should be able to do. We're going to find our median, then find quartile 1 and quartile 3, and then subtract quartile 3 from quartile 1. Well, Miss Baker, I don't know what the quartiles are. I got you. So we're going to go through an example, and I'm going to show you exactly what I mean by the interquartile range. Okay? So let's take a look. Alright, for example number 1, we're going to find the mean, median, mode, and range, and the interquartile range. So the first four, we should be pretty familiar about how we find the mean, median, mode, and range. And we know that the first thing we need to do is put our numbers in order from smallest to largest. Well, you're welcome. I already put them in order from smallest to largest for you. So now we just need to set ourselves up for success and write down what we are trying to find the value of. Alright, so let's get to the mean, median, mode, and range. So you'll notice the interquartile range isn't written on this slide. I'm going to run out of space to write, so we're going to put it on the next slide. So we're going to do the mean, median, mode, and range first. So our mean, like normal, we add all of the numbers together, and then we divide by the amount of numbers that we have in our data set. So once we add all of these numbers together, we get 699, and then we have 8 values in our data set. We have 8 numbers in there. So once we divide that, we get 87 and 375 thousandths. So that is our mean, or our average. Our median, let's start crossing them off. Left, right, left, right. Uh-oh, Spadoodios, we end up with 2 numbers in the middle. But never fear, because you know what we have to do. We have to take that 86, add it to the 88, and once we get that, we divided it by 2. So 86 plus 88 gives us 174. We then divide that by 2, finding the average of those 2 numbers, and getting that our median is 87. Our median is 87. Our mode, the number that happens the most, well, this is one of those weird situations that we mentioned in our notes yesterday, where we have 2 numbers that happen the most. So we have 84 that happens twice, and we have 92 that happens twice. So we have more than one mode. Yeah, more than one mode. Now for our range, we take our largest number, 92, and subtract our lowest number, 82, and our range is 10. Our range is 10. So this is all review from yesterday. Now we're going to add that new piece, which is the interquartile range. The interquartile range literally means the inner quarters. So we're breaking down our set of data into 4 parts. So the interquartile range, we're breaking it down into 4 parts. So what we do is we take our data set and we're going to follow the steps that we wrote before. So step 1 was put the data in order from least to greatest. We did that. Good job. Second thing we need to do is find the median. We already did that. So our median was the number that goes right here in the middle. So our median is 87. Our median is 87. The median means that our data that is halfway through our data set. So our first half is all of this over here, and our second half is everything to the right of it. So now we've broken up our data set into halves. But what we need to do is find the quarters. We need to set it up and break it down into quartiles. So when we're representing that, quartile 1 is represented as Q1. Quartile 1 is Q1. We also need to find quartile 3. Quartile 3. Now you'll see that we have these little numbers that are kind of the opposite of exponents. So this is just showing us like where it goes in our data set. It doesn't mean we're doing anything to the letter Q. It's just like we're numbering it 1, 2, 3, 4. So it's a small number under the letter to the bottom right, not like our exponents. So now we're going to find the value of those interquartile ranges. Well, quartile 1 is right in the middle of our first half here, and quartile 3 is right here in the second half. So this is quartile 1, quartile 3. Technically the median is called quartile 2, and then the very end is quartile 4. But we only care about quartile 1 and quartile 3. So let's look at how we solve those. So we need to find the number between here. So let's pretend that this set here, let's change our color to purple, that this set here is a whole new set of numbers. Quartile 1 is the median of that new set of numbers. So we do like we did to find our other median. We cross off our digits until we end up with our numbers in the middle. So quartile 1 technically is 84 plus 84 divided by 2. Now, Miss Baker, they're both the same numbers. Do we have to do that? Yes. I want you to show your work, and I want you to show me so that I know that you know how we found our quartile. So that gives us 84 as quartile 1. Now we take a look at our second set of data, our second new set, and I'm going to change my color to red here because we're going to pretend that this is a new set of numbers, and quartile 3 is going to be that median. So we cross off our numbers, and then we get our 2 in the middle here. So we do the same thing we did with our first one, 91 plus 92 divided by 2. So 91 plus 92 divided by 2 gives me 91 and 5/10, 91 and a half. Now, now we've found step 3, which is quartile 1 and quartile 3. Now we need to do step 4, and it's quartile 3 minus quartile 1. So that we take our numbers. Quartile 3 was 91 and 5/10. We're going to subtract quartile 1, which was 84, and that's going to give us our interquartile range of 7 5/10. Oop, that's a 7 on 5. 7 5/10. So here we did step 1, which was finding our median, so our middle, and then we had our new half, the first half, we can find our median of quartile 1, and our second half is going to give us quartile 3 as our median. We subtract quartile 3 minus quartile 1, and bam, we get our interquartile range of 7.5. IQR, come on, Miss Baker, you've got this. The interquartile range, or IQR. Now, what do all these numbers mean? I promise you, tomorrow we're going to look at putting these into a picture. And once we have that picture, it'll help make it a lot more sense. First today, we're going to figure out how to calculate them, and then tomorrow we'll look at what it actually means. Okay, and so example number 2, we're looking back at our data from number 1, and yes, I do want you to write these questions. What is the best measure of center and measure of variation? So when we look, we need to see and ask ourselves, are there any outliers? And that question, are there any outliers, tells us whether or not we're going to be using, the median or the mean or the interquartile range or the range. So in our first set of data that we did in number 1, it goes from 82 to 92. We do not have any outliers. We don't have any wild, crazy numbers that are added to our data set. So we know that because there are no outliers, to find our measure of center, which is MOC, we're going to use the mean. And to find our measure of variation, we can use the range. Example number 3. Example number 3. So here is another question where we're going to have to extract our data or pull our data out of a chart. So we're going to have to pull it out of this chart that we have here to find our mean, median, mode, and range and interquartile range. So I want you guys to take a second, pause the video. I know you all will, because I know you're good, honorable kids. And I want you to try to figure out the mean, median, mode, and range by yourself. Alright, welcome back. Hopefully you paused the video and you were able to put everything in order from smallest to largest. Once you put everything in order from smallest to largest, you should have gotten that the average or the mean was 45 and 428 thousandths. The median, or the middle number, was 53. The mode was 53, because that is the number that occurred most often. And that the range was 55. So hopefully these are the answers that you've got. And now we're going to look at finding the interquartile range with that data. Okay, so step 1 for finding your interquartile range was putting the numbers in order from smallest to largest, which we just can't copy over from our first part of this example. And then we find our median. So our median in our interquartile range is 53. Now, when we have an odd number of values, it makes our life much, much easier. It makes our life much, much easier. because that puts our median here in a box by itself. So it gets to live in its own little box, and then we create our new halves around that first, or our median. So if we have a median just like this and it gives it to us nice and easy, we don't have to worry about dividing or anything. It's part of it's like it's in its own little bubble here. So for quartile 1, it gives us we have our new half, and our new half has 3 numbers in it. So we go bloop, bloop to find our median. That means our median of our first half is 39. Then we have our new half on the right, bloop, bloop. That means our new median for the second half is 56. So when we have our interquartile range, we take our larger number, 56, and we subtract our smaller number, 39, which gives us our interquartile range of 17. 17 is our interquartile range. So example number 4 asks us the same question example number 2 did. What is the best measure of center and measure of variation? Well, we do have an outlier in that data set. So if you notice, most of the numbers are between 39 and 59. But then we have this wild number 4 that's way far away than all of the rest of them. So that number 4 is our outlier. So because we have an outlier, when we look at our measure of center, we're going to use the median, and to find our measure of variation, we are going to use the interquartile range. Now, why do we use the interquartile range? To find our measure of variation, words. Because that gives us a better understanding of where the middle of our data actually is, and how far out our data is actually spread, other than just using the mean or the range. Example number 5, let's go ahead and take this data set. I want you to pause the video and take the time to find the mean, median, mode, and range of this data set. So I'll give you a couple seconds. Go ahead and pause the video. Pause it. Come on, actually pause the video. Pause the video. Okay, welcome back. Hopefully you paused the video and did the work and found that the mean or the average was 13 and 625 thousandths, that the median and the mode were 13, and that the range is 8. Now that we found that information about this set of data, let's go ahead and see if you can try to find the interquartile range. Alright, let's take a shot at finding the interquartile range on your own. So we're going to take that same information we used in the first part, and we are now going to find, with those same numbers, finding our interquartile range. So go ahead and pause the video again, and actually pause it this time in case you didn't pause it last time. Make sure you pause the video, try to find it yourself, and then hit play and see if you're right. Alright, welcome back. Hopefully you took the time to try this on your own. It's better to and easier to learn when you actually try things on your own and then check to see your answers. So for quartile 1, once we split our data set in half based on the median, we take our new first half and find the median of the first half, and that gives us quartile 1, which is 10 plus 13 divided by 2, since there's two digits in there, giving us 11 and 5 tenths. And for quartile 3, we take our new second half, our upper quartile, and find the median of that. So it's 15 plus 17 divided by 2, giving us 16. Our interquartile range is quartile 3 minus quartile 1. So we have 16 minus 11 and 5 tenths, giving us 4 and 5 tenths as our interquartile range. And our last example, example number 6, has us looking back at example number 5 and what is the best measure of center and measure of variation. Now, there were no outliers in our data set for example number 5, so which two are we going to use? Pause the video and give yourself a second to write it down. All right. So for the measure of center, with there not being any outliers, we're going to use the mean. And for the measure of variability, with no outliers, we use the range. All right, ladies and gentlemen, that is the end of the notes for today. You have quite a bit of time to go in and get your homeworks started, and you should be able to finish by the end of class. So today's homework is, of course, the same as the notes that we took today. It is due in the basket first thing tomorrow, which is the 14th, on Thursday. I have posted the practice set where in the Google Classroom, where you can go in and check to see if your answers are correct. Again, I am not grading the practice set that's in Google Classroom. You must do your homework on a separate sheet of paper and turn it in. The practice set, just like we had done last week, is only there for you to check your answers if you would like. If you have any questions, please feel free to send me an email or ask Miss Robinson. She can help you guys as well. I hope you have a wonderful day. I miss you all dearly. Don't forget you are loved, and I will talk to you in tomorrow's lesson. Have a good day.